And so with that, being very conscious of time, I will hand you over to Isabel, who's going to talk about what it means to build an artificial intelligence strategy.
There we go. Can everyone hear me now? Yes. Cool. I'm not a tech expert. I'm a strategist. And what I think is that scholarly communication doesn't have an AI or a tech problem. It has a strategy problem. So scholarly artificial intelligence has tremendous capabilities, but it is dramatically underutilized by is dramatically underutilized by organizations within scholarly communication, and it's basically a disaster because businesses all over the world are struggling with what to do about artificial intelligence. And they all cite the same kind of problems. They say they have competing investment priorities, that they have unclear use cases, that they have no idea what the ROI is. And we all have problems with not enough data, that the data we do have is poor quality or siloed. We are distinctly unagile organizational setups, and of course, a complete lack of, well, not complete lack, but a significant lack of data scientists and tech talent. And so if you look at this, I mean, it's pretty much a nightmare, isn't it? But if you look at it, these are all strategic problems, not technical ones. And it's only by addressing these that any organization can begin to unlock some of AI's potential. So, what is this potential, and how do we unlock it? Well, luckily, that's what I'm going to talk about. First up, what is AI? Secondly, what can it do? And thirdly, what the hell should I therefore do about it? Okay, yeah, so what is AI? Now, there are endless definitions. For fun, I've decided to pick Amazon's to make a bit of a change, because as it turns out, Amazon have also made a foray into the dictionary market. And they say that AI is the field of computer science dedicated to solving cognitive problems commonly associated with human intelligence, such as learning, problem solving, and pattern recognition. So not a bad definition, actually. But while these endless definitions can be instructive, I don't think they necessarily help us understand what AI is or how we might use it. And so, since AI is an incredibly broad field with almost infinite complexities, I've decided today not to go into technical detail, but instead to talk quite broadly about concepts and practicalities. So to start off, I thought I would share a few interesting conceptual ways to think about artificial intelligence that might help us understand it. And these come from Dr. Philip Gerbert, who's an AI expert at Boston Consulting Group, BCG. And Dr. Gerbert starts off by saying that artificial intelligence is an intuition machine. And here it rather contrasts with traditional computers that we might think of as being logic machines. Artificial intelligence, learns from experience, but doesn't necessarily know why it does what it does, which is an interesting way to think about what intuition is. And to illustrate, we can think a bit about how AI learns. In the very simplest terms, and AI algorithms don't have any particular innate ability, but as data is added and they learn more about their context, they improve their ability to move towards a goal. And so imagine that you were in a forest in the pitch black and in the middle of the night, and you wanted to get out. You wouldn't just start running because you'd probably bump into a tree or trip over a root. What you do instead is probably feel your way with very, very small steps. And after a while, you get a feel for how far apart the trees were, whether or not there were ferns on the ground or if it was bare. And you might start to be able to move through the woods more quickly and with increasing levels of confidence. But that doesn't mean, even if you started to kind of get the hang of it, that you couldn't at any moment trip over a tree root or get some new data. And then you'd have to pick yourself up and readjust what you thought about your surroundings and carry on from there. And this is, in essence, kind of what AI does, again, speaking very broadly. It makes a move, calculates the result, the distance between the result and the goal, and then adjusts the parameters in the direction of the goal. So that's the first thing to think about. AI learns from experience using data, but doesn't necessarily know why it does what it does. The next thing to think about is that while AI may achieve the same goals as humans, it doesn't necessarily do it in the same way that a human would. And again, Dr. Gerbert has I really like this example. He says that submarines don't swim. yes, they move through the water, but they don't do what fish or humans do to achieve that. They don't actually swim. And he says that we shouldn't expect driverless cars to mimic human-driven cars, just like we shouldn't expect, or would never expect, human-driven cars to mimic horse-drawn carriages. And for me, there's an obvious parallel here from the move from print to digital, where basically what we did was digitize print workflows. And in the future, this is not what we want to do. I mean, it's a terrible approach anyway, but we particularly don't want to do it with AI, because with AI, it works much better to think about goals and not about processes. So there we go. AI is an intuition machine, it learns from experience, and it doesn't swim. Definitely don't drop it in the water. With these kind of qualities, what is it that it can actually do? Well, PwC have a rather nice quadrant, which I'm going to talk you through, which has two axes based on how hardwired or adaptive a system is, and how involved a human has to be on the other. And I'm going to start very broad here and then move into more specific examples. So this is the broad overview. First up, and again, this is how you can think about what roles AI could potentially play in your organization. First up, you've got automation, which are manual, repetitive tasks where AI can help where humans might be slow or less efficient. Then you've got assisted intelligence, which is where artificial intelligence systems can help humans perform tasks quicker or better. Then you've got augmented intelligence, which is helping humans not to do things quicker and better, but to actually make better decisions. And these learn from their interactions with humans and with the environment. And then lastly, you've got automation intelligence, which is AI systems that can adapt to their surroundings and act autonomously. So these are four broad categories. To go deeper, PwC have this very nice visual, which looks at AI's capabilities and that sort of techniques and sorts them into layers. So you can see here you've got the foundational layer, which is some of the research fields that support AI, like computer science or statistics, obviously being a massive one. Building on that, you've got the cognitive layer, how AI systems actually structure their information and sort of come to decisions, and you've got some of the processes there, like machine learning, deep learning, neural networks, etc. Then on top of that, you've got the behavioral layer, where some of these cognitive systems actually interact start actually performing maybe useful tasks like machine translation or robotics process automation. And then on top of that, you've got the sensory layer, which are systems that enable AI to interact with people and with the environment, like natural language processing, machine vision, navigation, that type of thing. But given AI's, again, infinite complexities, I'm going to focus on one area, which is deep learning, and look at some practical examples. And I'm going to look at non-industry examples and then scholarly comms examples. Deep learning, again, a multitude of techniques, but you can pretty much categorize these into 8 main categories, and here are the first 4. So classification is where, based on a set of training data, a system will categorize a new input as belonging to a set of predefined categories. So you can think of YouTube being shown loads and loads of cat videos, being told that these are cat videos, and then being able to see a new video and knowing that it's also of a cat falling off a table or whatever the cat is doing. YouTube, Twitter, Facebook, etc. also use this to identify inappropriate content and things like that. In scholarly comms, you could think of it as it's already being used for things like document classification or assigning content to a taxonomy. Second example is, or second use case, is anomaly detection, which is a bit like a subcategory of classification, where, again, a set of training data, new inputs can be seen as being unusual to what it's being told to look for, and you get this a lot in engineering. Like you might monitor an engine and see whether certain vibrations are normal, and if they go outside the normal bounds, then you've got a problem. And it's also used in banks for fraud detection. There are 2 companies doing that. And in scholarly communication, you could potentially, I guess, use this in peer review to look at whether a particular statistical test is actually an inappropriate one to use in a situation, or maybe a listed co-author is actually very unlikely for various reasons, things like that. And you've got clustering, which is to do with looking at the data set and drawing up into particular categories, drawing categories out of the data. And an example of this might be customer segmentation. And Netflix have been incredibly successful here by no longer grouping customers based on traditional categories like age, gender, or geography, and looking instead for taste, which just arises out of the data and can't be sort of predefined. And obviously we can use this in scholarly communication to move beyond looking in discoverability to looking beyond research disciplines. We've got continuous estimation, which can be used to predict sales demand based on weather, new trends, maybe social listening even, and make predictions. And then you've also can use this in scholarly communication for maybe predicting how many citations a paper will get. Bear with me, we've got 4 more, sorry. These are quite quick because recommendations, fairly obvious. We're all quite familiar with Amazon, Netflix, and Spotify, and maybe picking the next book to read or journal. Ranking is the last set, sorts information into the right order, ranks it basically, and it's usually the last step in a search engine, which pairs up with recommendations. So you have you can pair those two up quite a lot. So you've got the recommendations, and then they're ranked in order to present to the user. Then you've got all other optimization, because optimization can be the goal of a lot of these things, but it also has specific other examples. So like Deliveroo and Uber would use this to find the best drivers for a particular route. Cargo companies, shipping companies use it to optimize fuel or time savings. I think we can be a lot more creative in scholarly communication to use it for improving website design or researcher engagement with content. Data generation, you give a system loads and loads of data, and then it will create something new that's appropriate. So you can give it loads of music, and it might create a synthetic song. You can give it loads of journal articles, it might write a new journal. And so with all of this, I think you can see there are quite a few exciting use cases for scholarly communication. And these basically they span operational efficiencies, website design, sales, marketing, discoverability, endless others. So that was a bit of a whistle-stop tour. I do apologize for that. But knowing what AI can do with some examples, I think, makes it easier to think about where it might apply to different parts of your business, which in turn will then make it easier to prioritize. Assuming that you still with me, then and you're feeling convinced that you want to get a little bit involved, then what do you do? Number 3, what should I do? And this is really what I want to talk about. What should I do? First up, on no account, invest in AI. Don't do that. Invest in a business problem. AI is a tool like anything else, and it should be evaluated to see if it's actually the right thing for the job, because there's an awful lot of hype around it, and it also has a lot of specific requirements and ongoing maintenance needs. So you need to rationally evaluate whether the cost versus benefit ratio actually makes it worth it, and it is completely fine to say that it isn't. But if you do look at where companies globally are getting value from AI, then what's interesting is that they tend to be using it in the core parts of their value chain. And this is different from other emerging technologies, which you tend to find on the peripheries. We're seeing it really, really in the core of businesses, making very tangible differences. And McKinsey have 4 areas where AI is having particular impact in the so-called value chain, which you can see here. So first up, you've got prediction about future trends which can inform product development, sales, R&D, all that sort of stuff. Then you've got producing more products more efficiently, more quickly, more cheaply, whatever. Promoting the right products to the right people at the right time. And then providing an enriched or personalized user experience. And that can both be on a website or making sure that someone gets their coffee just how they like it. And if we look at this and apply it to traditional publishers, then I think you can kind of hone in on particularly produce and promote as being 2 key areas. Produce, you can think about editorial and production, and promote sales, marketing, and discoverability. And I think this also quite nicely equates to the simple dichotomy between top line and revenue generating impact and bottom line efficiencies. We really are very, most businesses would be able to see considerable improvements with discoverability, sales, and marketing with better predictions of demand and article recommendations and such like, and advertising. And on the bottom line, it can help with production costs, supply chain management, and the stocking of books in your warehouse or whatever. Of course, talking a little bit about traditional publishers there, but the way that publishers are creating value is changing. And things like discoverability, analytics, text and data mining, author services are all now key parts of a publisher's offering when they weren't even 10 years ago. And I think artificial intelligence is only going to exacerbate these types of shifts because it impacts the way that industries as a whole and professions create value. Think of the changing role of the radiographer now that computers can better read X-rays and spot cancer and such like, and how the role of the taxi driver might completely disappear with driverless cars. I think we need to think very carefully how using AI or just being affected by AI at a society level will impact how we create value for research in the longer term. So in addition to value creation, I want to look briefly at two other important areas that I think are particularly important for scholarly communication and that will impact or should impact strategy. And these are competitive advantage and partnerships. First up, competitive advantage. Improved production efficiency or discoverability can be key ways to gain a competitive edge. But as soon as everyone starts automating the same parts of a journal workflow, what starts off as an advantage just becomes the normal cost of creating a journal. And so developing and sustaining competitive advantage is going to change. And I think that we're going to see that data is going to be a key way to be able to create competitive advantage. And in particular, having access to unique data sets that your competitors do not have access to. Because unique data enables you to create unique insights, products, and services on top of it. And then the second area is partnerships. Because as I said, data is going to be already critical, but increasingly critical. And it's siloed across and within publishers, research institutions, vendors, everywhere. And no one organization is going to have all the information that it would like to. And this means that we're going to need to be more creative and open with our partnerships. We've seen relationships shift in other industries. For example, Walmart now shares huge amounts of data with fast-moving consumer goods companies in shared data lakes, and this ends up creating a lot of value and improvements both for the supplier and on the supply and the sell side. And scholarly communication, while very collaborative, I think could be considerably more proactive and open in its relationships. And another reason that this is going to be particularly important is that most AI talent sits with the vendors. We obviously can't imagine or can't kid ourselves that small university presses or even large but digitally slow-moving legacy publishers are going to be able to build state-of-the-art AI technical teams. There are not enough AI experts in the world to go around for Google, let alone for us. And most businesses aren't actually set up to make use of them, even if they wanted to. And the good news, though, is that you don't need to, because AI is increasingly becoming commoditized. You can use AWS for image recognition. You can train up a software developer to use Google TensorFlow. And you can get data consultants and vendors in to look at your data and help you work out what might be possible with it. And John is going to be talking a little bit more about this type of thing in a moment. And the third area that I think is particularly key for how AI will affect partnerships is in terms of partner relationships and the structure of the relationship. Since you can't just buy AI and plug it in, the data and the training are crucial, you often end up developing a joint product with a vendor, which means that ownership and development become increasingly important and can become issues. And so structuring the relationship and contracts carefully is crucial. So these themes, value creation, competitive advantage, and partnerships, all add up to one big question that you may well have, which is, do I buy or build? And again, I really like this. BCG have quite a nice way of looking at this, and they say to put the access on one side, how essential is the data that you have for your competitive differentiation? And on the other one, how unique your data set is versus any vendor. And if you look at it like this, it actually becomes relatively easy to think about where you might buy and build in a broad sense. If you've got an incredibly unique data set that's critical for your competitive advantage, then potentially you might want to consider building. But certainly if you're looking to create efficiencies in production or something like that, then that's not something you want to be developing yourself. And if you ever end up finding that you're developing some new machine learning technique, then you're probably doing it wrong. And if you're, after all this, absolutely gagging to give it a go, then McKinsey have pulled out 5 areas that they consider to be absolutely crucial to a successful AI transformation. And these are having the right business case, as we've talked about, building a data ecosystem, getting the right tools and techniques, integrating throughout your current workflows, and adopting an open culture and reskilling the workforce. So this is all very well. And even running through these quite quickly, they probably make sense, not rocket science. But I thought, especially given everything I've been talking about so far, it might be fun to look at this in a completely different, slightly off-the-wall way. So bear with me. I thought, what if we think about AI not as being an abstract algorithm, but instead, or abstract algorithms, instead we thought of it as an alien pentapus. Well, that's like an alien octopus with 5 legs, one for each of McKinsey's five things. And the reason this idea came to me one night, obviously, was that artificial intelligence, in a way, is a little bit like an alien because the value doesn't reside in the algorithm. It comes to Earth, or it comes into your business completely naive with no inbuilt capabilities, really. The data and the training and supervision are key. And you have to, in order to be able to make use of it, you have to make operational changes and organizational changes and focus on the data and all that sort of thing. So it's basically like a little bit like an alien.
3 or 4 minutes.
Okay, that's fine. That's pretty much all I've got. And so we can now, with our little alien, apply McKinsey's 5 things to it. First up, get the right business case. No case, no point. Don't bother. Focus on the goal and then select the means. And just because your competitors have an AI alien and you think it looks cool is not a reason to get one. It takes a lot of looking after. Remember, an AI alien is for life and not just for Christmas, or even this financial year. Second is building a data ecosystem. In order to learn, the AI alien needs data, loads and loads of delicious data. But she's very, very fussy, and she only likes data in a particular structure, particular quality. She wants absolutely loads of it, often needs to be told what she's eating. And if you don't do this, or if you don't focus on bias, then anything that she says will be nonsense. And you're not going to be able to, so if you can't get your data house in order, then you're not going to be able to feed her. Third up is tools and techniques, because let's face it, unlike looking after your standard analytics animal or database dog, an AI alien pentapus needs special handlers with different skills and completely different ways of working. And so you need to think really hard about what talent you need in your organization and whether you need outside help. And this, again, is where partnerships become relevant, because maybe you want to take a borrow my doggy approach, where the vendor keeps the AI, but you get to have some of the benefits. Fourth is workflow. You've got to integrate through your entire workflow, because there's no point going to nurture your little AI alien into growth if you keep it outside in a kennel. Don't do that. It's got to be like right in the middle of the organization where it can learn about everything and impact everything and have the best access to all the data. And then lastly, you've got to have an open culture and reskill the workforce. Because, let's face it, if an AI alien turns up at work, it's going to be a bit of a shock. Most people are going to be like, whoa, what's this? And not everyone is going to like the change. So building trust within your organization is key, as is in ensuring that people are brought along for the ride and that they're reskilled and they understand how to work with it and they can develop the right domain knowledge to actually be useful. We have a huge number of intelligent, enthusiastic, keen and technical people in scholarly communication, and I think we could make more use of them by really investing in development. So there we go, AI as a business transforming AI alien. She can help, but she will only thrive and not drain your resources if you fully commit your organization. So Phil will be really relieved that I'm going to sum up. In summary, AI can do a lot of stuff. But you need a business case, and AI is not always the answer. We need to think differently about competitive advantage, partnerships, and vendors, and change our organization, the structure, people, processes, and data. Because the way that businesses and research work is going to look very, very different. But don't worry, everyone is facing this. So being honest and preparing now, even if you can't act now, preparing now will allow you to take advantage of the possibilities in the future. There are some really big and brave decisions, I think, that scholarly communication needs to make. And it's tough. But if you want your future to look more like ET and less like Alien, then you have just got to do it. Thank you.